So now we've created a database in Azure, we've connected to it using Management Studio, we've looked at how we can drop it using the portal. We've got a database in there, we're able to connect to it, we're able to work with it. It's probably a good opportunity to discuss the differences between Azure SQL databases and some of our on-premises SQL servers. Now, Azure SQL Database, it's a platform as a service offering. Lots of the administration, lots of the overhead, lots of the management and maintenance is taken care of for you by Microsoft. Okay, so some of the features in Azure will differ from the on-premises version of SQL Server. And we're going to look at some of the important features here where there are differences between the two platforms and products. So where there's some differences, backups and restores. Backups do happen in Azure, but they happen automatically. There's no need for you to go in and schedule them. This is part of the roles and responsibility that the platform as a service offers you. Conventional databases, backups and restore statements aren't supported. Okay, so backup database to and restore database from. The backups are scheduled and start within a few minutes of the database being provisioned, and the backups are transactionally consistent, which pretty much means you can do a point of time restore. There's no additional cost for the backup storage until the backup storage goes beyond 200% of the provisioned database storage. And you can do things like reduce backup retention and how long you keep your backups for to manage the storage cost of your backup. There's a feature, or a long-term retention feature, where you can set a period of time longer than the standard to store your backups in the Azure Vault, and that is at a much smaller cost for the longer duration. Other than the automatic backups that Microsoft take care of for you, you can export the Azure SQL database using a backpack or a DACpack file to Azure Storage. There's no conventional way for you to be able to run traditional backup statements from Azure. And the recovery model. The default recovery model is full, and this can't be modified. Okay, so the default recovery model of an Azure SQL database is full. It can't be modified to any other recovery model, which you can have on site. So you can have things like simple and bulk logged on site. The recovery model is set when the master database is created, and this means when an Azure SQL Server is provisioned, the recovery model can't be modified. Okay, the master database is read-only, so you can't change that. Another difference between Azure SQL Database and the on-premises version of SQL Server is the SQL Server agent. Azure SQL Server doesn't have a SQL Server agent. Now, for those of you that have been working with SQL Server a long time, you're going to be well aware that the agent is used to schedule jobs, send notifications. It's got a lot of useful roles in the toolbox of a DBA, and it just doesn't exist in Azure. There are some workarounds to this. Okay, you can use an agent on premises on an on-premises version of SQL Server, or you could spin up a SQL Server VM in Azure with a full-blown version of SQL Server on it and run the agent from there. There are obviously costs associated with running a VM in Azure as well as having your database there, but it will get around that for you. There's a tool called Azure Automation. This allows users to schedule jobs in Microsoft Azure. Basically allows you to automate things. So kind of like the SQL agent, but whereas the SQL Server agent is focused solely on SQL Server, the Azure Automation tool is for a multitude of different features in Azure. Elastic Database Jobs. Elastic Database Jobs is a cloud service that allows the scheduled execution of ad hoc tasks, and we're going to look at this topic in more detail later in the course. And we can use PowerShell, to automate tasks and then schedule these scripts to run from a Windows scheduler on premises or using an Azure SQL VM SQL agent. So again, comes back to having to run the schedule from somewhere. Other features that are not available in Azure SQL Database include Change Data Capture. Now, Change Data Capture, or CDC, allows you to capture data modifications that have occurred on databases and tables that have got CDC enabled. Now, this feature is particularly important in incremental load scenarios, where maybe you're loading a data warehouse from your transaction systems. So the CDC feature requires the SQL Server agent, and the agent is not available in Azure SQL databases. However, there are some workarounds. You can use temporal tables, SSIS, or Azure Data Factory to implement CDC. Now, another feature that is not available in Azure is around auditing. Back in SQL Server 2008, an auditing tool was introduced that was based on extended events. That's not available in Azure SQL databases. And some of the other auditing features like C2 auditing, SQL default trace, both of which have been around a lot longer than the extended event auditing feature, or anything that writes alerts or issues to the event log, they aren't available. And this is because it's a PaaS offering, it's a platform as a service. Microsoft are managing and maintaining that for you. You don't have access to those logs. Other differences between Azure SQL Database and SQL Server include database mirroring. You can't enable mirroring between two Azure SQL databases. You can, however, configure an Azure SQL database as a mirror server. You can set up a readable secondary for an Azure SQL database, which is probably better than mirroring anyway. Other differences include table partitioning. Table partitioning using a partition scheme and a partition function is allowed in Azure SQL database. However, because of the PaaS nature of the Azure SQL database, all partitions should be created on the primary file group. So you won't get the performance improvement of spreading your partitions across different disks or spindles. However, you will get a performance improvement of partition elimination. Following on from the differences between Azure SQL databases and the on-premises version of SQL Server, we have replication. Now, conventional replication, such as snapshot, transactional, or merge replication, they can't be done between two Azure SQL databases. However, an Azure SQL database, it can be a subscriber to an on-premises or Azure VM SQL Server. This too, though, has some limitations. It only supports one-way transactional replication, so it doesn't support peer-to-peer or bidirectional replication. It supports only push subscriptions, and you should have SQL Server 2012 or above on premises. The replication and distribution agents can't be configured on Azure SQL databases either. Multi-part names is another difference in behavior between Azure SQL database and on-premises SQL Server. If you've been working with on-premises SQL Server for a while, you might be used to referencing objects in a different database that sits on the same server using a three-part name, or even accessing objects that sit in the database on a different server using a four-part name. With Azure SQL database, you can't access tables in a different SQL database that sat on the same Azure SQL server using three-part names, and four-part names, server name, .database name, .schema name, .table name, aren't allowed at all. You can use Elastic Query to access tables from different databases from an Azure SQL server. Now, we're going to look at Elastic Query in a bit more detail later in the course, but you can access objects in different schemas in the same Azure SQL database using the two-part name, so schema.objectName. There is a document on the Microsoft website, basically Books Online, that will allow you and demonstrate to you the differences or other differences in Transact SQL and how they differ across on-premises SQL Server compared to the Azure equivalent. And you can see that link on the screen there.